All right, this first example, it says find the arc length of this function from 0 to 10. And this function is just a line, so it's really kind of overkill to use calculus for this. So tell you what let's do. Let's figure it out just using the Pythagorean theorem, and then we'll use calculus just to verify that the formula that we've got up here works. So let's do it to begin with. We've got here 3/5, it's going to look like that. So over here at 10, let's see, what's the y-coordinate going to be? Well, the x-coordinate's 10, the y-coordinate's going to be 10 times 3/5, so that's going to be 6. So you've got a triangle with a length of 10 and a height of 6. So what's the arc length going to be? That's the length of the hypotenuse. So that's going to be 100 plus 36. So 136. So what is that? Square root of 136 is 2 root 34. Okay, so the length of that hypotenuse is 2 root 34. I'm going to put that up here just to kind of save it. Let's see that using this formula is going to give us the same thing. All right. Well, my derivative here, dy dx, is 3/5. And so the ds is going to be square root of 1 plus 3/5 squared. Let's go ahead and square that. You get 9 over 25 dx. And let's see, if you add that up, 25 plus 9 is 34 over 25. That looks promising. And of course, you could rewrite that as 1/5 root 34. So now we're notice this is ds is equal to that. So if we integrate ds from 0 to 10, we're integrating 1/5 root 34 dx from 0 to 10. So that's root 34 over 5 x from 0 to 10. So it's just root 34 over 5 times 10, and they cancel and gives you 2 root 34. All right, so 2 root 34, that's our answer, and it's what we got from the just using geometry. Tell you what I want to do. Let's skip this example 102 and let's do 103 next, because it's a nicer example. It says set up an integral for the length of one cycle of y equals sine x. Evaluate it using Desmos or another calculator. Now, the reason I'm saying to evaluate it with Desmos is because some of the integrals that we get from these arc length problems are particularly nasty to actually do. So we can set this up easily though. Our dy dx, derivative of sine is cosine. And so our ds in this case is going to be square root of 1 plus cosine squared x dx. And it's always tempting to try to replace that with sine squared, but we can't. If that were a minus, it would be sine squared. So what I'm going to do is I'm just going to leave this as, I shouldn't say equals, the arc length is going to be integral square root of 1 plus cosine squared dx from 0 to 2 pi. Because you know that this is supposed to be one cycle of sine goes from 0 to 2 pi. So this right here should give us the length of that. Now let's use Desmos to compute it. Switch over to Desmos here. I'm going to type in integral. Try that again. Type in integral from 0 to 2 pi of square root 1 plus cosine squared. Will Desmos take the square up there? I'm not sure. Dx. Yeah, no problem. So it gives us 7.64. And I'll just round to 2 decimal places. All right, I want to do this other example up here, but we'll wait till the next video for that one.